Hi there once again, and welcome to another Expresso mechanic tutorial. And in this one we are going to be looking at Planetary Gears, and I was recently approached by Ruben Hoogland, I think is your name, from the Netherlands, and he was interested in having this particular scenario looked at. So I thought, well, why not? I'll do this one and it'll be the last tutorial of 2023. So we've got the gears here, and we can see that if we move the sun gear, the planet gears all react accordingly. And I've set up 6 different scenarios here because we can use the sun gear, we can use the ring gear, and we can also use the carrier here to either drive any of the other two. That's how they work. So we'll tackle all the scenarios. I've also created the ability to reset everything to 0, and then we can simply go into here, switch this one off, switch this one on, and if we move the ring cog, we'll find that we get, if we switch off the reset, if we move the ring cog, we'll get the opposite scenario. So there you go, that's how this is going to work. Anyway, that's what we're going to be about in this tutorial. So without further ado, let's see if we can make this happen. We'll start by bringing in a cogwheel, and this particular cog is set up exactly as we need it because it has 20 teeth, and that's what we need, and we'll leave everything else alone. We'll copy this one, so command drag to copy, and this will become our ring gear. For a start, we'll give it 40 teeth, and then in the inlay here we can just expand this out until it goes past somewhere around there. I think will do nicely. So that's our sun and ring gears. Let's rename them sun cog, and we'll call this ring cog, or ring gear, that'll do. Moving on from here, we'll copy the sun cog again, so command drag to copy that, and this one will be the planets. Now the planets actually need 10 teeth, and that's the correct size for that. So we'll simply call this P1 cog. So that's our planet 1 cog, because we're going to actually have 6 planets. Now in order to position these, we need to bring in an end side, and that will be our next port of call. So we'll bring in our end side, and it's already perfect because it's a hexagon, and that's exactly what we need it to be because we want 6 ring cogs, or rather 6 planet cogs placed around it. So what we'll do first is expand its radius to 300. That's where it needs to be. And then we can select our P1 cog, go into our tools, duplicate, and we wish to duplicate 5 copies, which we've got it set to, and that needs to be along the spline, which is the end side. And we've done it. Fantastic. So that's all set up and it's working as it should. Beautiful. Now the next thing we can think about then is making our cogs into physical objects as opposed to simply being splines. Obviously we need to place them into extrude, so we'll select all of our cogs, hold down the option key and drop them into extrudes. The extrudes need to be just 50. That should be fine for what we want. And what we'll also do is go into garage shading lines, and what we've got here, we've got a slight problem. So what we need to do with our ring cog extrude is make it -50, and that lines everything up perfectly. We'll also switch to isopalms just to make things a little nicer, and then we can think about our extrudes. Now we want to work with the caps and just make sure that they all match up. So let's see what we can do here. Go into our caps. We want something like, let's see what we've got. So try 1 for the size. Yeah, I mean 1 isn't too bad. We can go 2, I think. Yeah, I think 2. That's really nice. That's looking great. So I think that'll do fine for that. Then we can think about doing some renaming. So our sun cog, we'll just call that sun. The second extrude ring. It's only really to distinguish them. P1, P2, P3, P4, P5, and finally P6. It's just so that we can distinguish them. That's all that is really. Okay, great. So we've got it that far. Now this N side is going to actually be the carrier for the planets. So we don't want to do anything with that. But we do need a second N side. So we'll create one of those. Have a look, see what we can do. Select the N side, command drag to create that. And this will be the, well, it will be the true carrier or the actual physically represented carrier. The N side that we've got as a spline will actually carry the planets, but this is going to be the physical carrier. So what we need to do here is switch to our front view, so F4, and then we can start to have a look at this N side, and it's got to be bigger. We've obviously got to get it to just beyond the radius of this circle. That's where it needs to be. That's what we've got to achieve. So let's see what we can do. If we just take it to somewhere around there, I think that will be fine. 333, and then we can also round it. That's looking reasonably good. We can go a bit further actually. Let's just take that out to, let's go 340. I think 340 looks really good. Switch back to our 3D view, so F1, and then we can drop this into an extrude. Drop it into one of those. Obviously much too big. Let's make it 20. And then we'll physically move it to where we think it should be, which is going to be somewhere behind the various cogs. Let's have a look. So if we switch to our right hand view, we can see it there. Let's just go beyond them slightly, somewhere there. We don't need the snapping on now. Just go somewhere there by eye. That should be fine. And now we've got the carrier in place. Okay, fantastic. So that's all looking really nice. The next thing that we can do is actually bring our N side here down to just below our ring, and we can select all of our planets and drop them into it. And that way, when we rotate this, we should find everything works as it should so far. And forgive that ding, that was just my phone. I'm expecting a call that I've got to take a bit later. But yeah, that's fine. That's all working as it should. The next step then is just to bring in some little axles that can be arranged around the N side so that we've got those attaching our planets to the carrier. And that's the next thing we're going to do. Before we do that, what we'll actually do is select everything and hold down Option, press G, and we've grouped everything into a null. We'll call this Planetary Gears, and that's fine. That's got it that far. This we can call Physical Carrier, and this N side Carrier, because that's the true carrier. Okay, so that's all looking quite good. We can also drop this down here. Just put it above our carrier. And we will drop all of these. We just select, shift select the carrier and this, so that we've got both selected. Option G again, and call this Carrier Assembly. Just put the E in there, Carrier Assembly. Okay, fantastic. And that should mean that when we rotate this, all of it rotates now, including the physical carrier, which is what we need it to do. Fabulous. Great, so that's all set up and working the way I want it to. There's a bit more to do because we need to put some other bits and pieces into the carrier assembly. So let's grab a hold of a cylinder. The object in the radius 15 and 60 in the height. In the caps, we can fillet it. We'll just put a 1 centimetre fillet on there. and leave that as it is, that's absolutely fine. And we just need to orientate it plus Z. That's fine. And we can see that it's in the middle of the sun gear and it's working as it should. The next thing we can do is what we did before, go into our tools, duplicate, it's all set up. We can just hit the button and we've got them in the correct places. And then all we need to do, drop this in here. These cylinders we can then move into into their correct positions. Let's just get a hold of them and just move them by eye so they're about there. That looks great. That will be fine. Okay. So we've got our gears in place. In fact, we'll just go a little bit further back. Somewhere there. And that all looks really nice. That's going to work for us. So these cylinders, we can just grab a hold of them and drop them into our carrier assembly because they need to be part of that. And we'll just call these, I don't know, axles. That'll do. We don't have to do anything with them, so we'll just leave them as they are. And we just need one more of those. What we can do, grab a hold of this one, Command drag to copy. And then this one we can drop into our planetary gears above the sun and zero it out. And that just gives us our center. And we can just move that one back to about there. Yep, all looking really good. So we've got everything set up now and it's all ready to work. Moving on from here then, we can think about making this thing animate correctly and start by creating our first Expresso expression. We'll create a null, name it Expresso, give it the Expresso tag. We've got the editor open and we're ready to start doing some work. The first thing that we need to bring in is the sun cog. So we'll bring the sun in and we're working with its rotation B. So rotation B. Moving on from here, we'll bring in two range mappers. Got our first one, we'll command drag to create a second, and we can plumb the output of the sun into the inputs. We can then think about where we're going from here. We may as well bring in all of the elements that we wish to work with. So we need the carrier assembly. We'll bring that up to there. Again, at the input stage this time, we want rotation B. And then we also need a hierarchy node. So we'll bring one of those in. And there goes my phone again. So let's bring in a hierarchy. Now, this hierarchy needs to reference the axles because it's, or rather, is it the axles? I beg your pardon, it's not. It's going to actually be the carrier because we're going to want to work with the planets. So we'll bring the carrier into the reference so that we're referencing that. And then we can carry on from here and bring in P1. So we've got P1 in there. And once again, we can say, what we want coordinates transform position, we might as well do that, or rotation, I beg your pardon, rotation B, bring that in. And then we'll also give it an object port because we need one of those. So we're there. So we need to feed these from the hierarchy into the object so that we're sequencing through all of them. And then we can work with our range mappers to get these things rotating in the correct way. What is the formula for working this out? Well, we know that our sun gear has 20 teeth. We know that our ring gear has 40 teeth, and the sum of our planets is the sum of the sun gear's teeth plus the ring gear's teeth. So add 20 to 40, you get 60. We've got 6 cogs, each with 10 teeth, so that works out. That's important because you must have that correct. If you don't get it correct, things won't work. The gears just won't mesh correctly. So that's the golden rule. Add the sun gear's teeth to the ring gear's teeth, and that gives you the sum of the planet gear's teeth. Let's move on from here. Now, we'll use our sun gear as the input on this occasion, and we'll use our carrier as the output. So the sun gear is going to drive the carrier. So that means that if we get the calculator out, let's just get that on the screen. We have got 60, because we're driving all of these, divided by 20. That's the formula that we've got to use, and we get 3. Now, if we divide 360 by this 360 divided by 3, we get 120. And that 120, of course, will be 120 degrees. So every time our sun gear rotates through 360 degrees, our carrier needs to rotate through 120 degrees. So it's going to take 3 revolutions of the sun gear to move the carrier through 1 revolution. That's how this is going to work. So let's bring the Expresso back onto the screen, and we can place this into our range mapper. So we need degrees for the input range and output range. We'll set those 2 up. 0 to 360 will indeed be the input lower and input upper. Output lower will be 0 again, and we just need to put 120 in our output upper. And we can then connect this to the rotation B of the carrier assembly. We won't move anything yet. We'll do a test once we've set up the planet gears. Now, how do we drive the planet gears? Well, it's perfectly simple in this case. What we need to do is simply add the 120 degrees to 360 to give us 480. But of course, the planets need to rotate in the opposite direction of the sun gear. So therefore, if we set this one up with degrees at the input and output stages, 0 to 360 once again, and this time 0 to minus 480. And we can then plumb that into the planets. And if we now move the sun, we should find, all things being fair, that we get the result that we want, and we do. There you go. So our planets and our carrier are both moving exactly the way we need them to. Just undo that to reset them back to 0, and we're ready to move on to our next expression. And all we need to do is physically copy this first one. So we'll do that, copy that to there, select this one, switch it off, and then we can work with this one. Now we'll do the inverse next. So we'll use the ring cog as the driver, hold the sun in its current position, and move the carrier. So how do we work this one out? Well, perfectly simple. We know that the carrier, once again, if we get the calculator, cancel that, we know that the carrier has 60 teeth, and we know the ring has 40, so we'll divide 60 by 40 on this occasion, which gives us 1.5. Divide 360 by 1.5, giving us 240. So we know that in this range mapper, the output on this occasion will be 240. And that makes sense because we've got double the number of teeth, so we've got double the number of degrees, so 240. In our second range mapper, let's just get that calculator back. What we actually need to do is divide 240 by 2 to give us the 120. And then we can simply add that to the 360, giving us 480 once again. So let's go back into our Expresso, into our range mapper, and on this occasion all we need to do is remove the minus sign. The last thing we do before we test this out is drop the ring into here. So we've got the ring as the driver, the carrier assembly as the driven, and now we can select the ring, and if we move it, we find that we get the result that we want. Beautiful. Command Z just to reset that back to 0. Fantastic. So all we need to do is select this one, Command drag to copy, switch the previous one off, this is ready to go, and we can think about our next scenario, and that will be the ring as the driven cog, the sun as the driver. We'll get a hold of the calculator once again and start doing some calculations. So we know that the ring gear has 40 teeth, and that's the driven, so we'll divide 40 by the 20 teeth of the sun gear to give us 2. If we divide 360 by 2, we get 180. If we open our range mapper, our first one here, we want minus 180 in there, because of course, once again, we're going to be driving these cogs, and they're going to be pushing the ring gear in the opposite direction of the sun gear. So the ring moves in the opposite direction to the sun gear. Moving on from here, we can worry about our planets. Well, we know that our sun gear has twice the number of teeth, so therefore we need to place 720 in here, because of course twice 360 is 720, and it will be minus 720. Let's see if that actually works. We'll bring in our sun cog, or rather our sun, I should say. Our sun needs to be brought into here, and we can see if this actually does work. But of course our carrier assembly is still in here, and we need that to be our ring, so we'll bring that into there. And then let's see if our setup works, and it does. We can see that our sun and ring gears and our planets are all behaving as they need to. So that's our third scenario taken care of. Let's zero everything out by Command Z. Copy this, select the previous one and disable it, and we're ready to start work once again. We'll calculate the inverse of what we've just done, so this time the sun will be the driven gear and the ring the driver. If we grab a hold of our calculator once again, we therefore need to divide 20 by 40, giving us 0.5, and then we can divide 360 by 0.5, giving us 720. Now, obviously, we want our sun gear to rotate in the opposite direction to the ring gear. So in our range mapper, we need to place minus 720 as the output upper. Everything else is fine, and then we can worry about our second range mapper and what we're going to place in there. Well, we know that with the ring as the driver, the ring has 40 teeth, these have 10, so they're going to rotate 4 times for every single rotation of the ring gear. So 360 times 4, it's 1440, but let's calculate it. 360 times 4 times, oops, hang on, let's just do that again. 360 times 4, oh, that's not right. 360 times 4, 1440, just to prove it. So in our second range mapper, we can place 1440 in there. 1440. Again, we need to do some work with swapping things around. Our sun needs to be where our ring is, and the ring where our sun was. And now if we select our ring and move this, we get the result that we need. Fantastic, so that one's working. We'll copy this one, disable the previous one, and we're ready to look at our next scenario. So what we're doing here is using the carrier to drive the sun gear. So our carrier, let's get the calculator. Our carrier has 60 teeth, and we need to divide 20 for the sun gear by 60. Divided by 60 gives us 0.333 recurring. So if we divide 360 by 0.333, that should do fine. We get 1081 point, etc. But what we'll do is round this down to 1080. Okay, so let's go into here, into our first range mapper, and we'll place this in here. So it will be 1080 in there. We can then work out what we're going to be doing with our planets. On this occasion, we're actually quite lucky because all we need to do is put a minus sign in front of 1440 and we'll get what we want. Let's just try this, and we do. Fantastic. So we've got that scenario working correctly. All we need then is our final scenario. So we'll click and drag, or command drag, and switch this one off, double click to select this one, and then we're ready to start work on our final scenario, which will of course be the ring cog being driven by the carrier. We'll get the calculator and let's see what we get when we do the calculations. So we know we're going to divide 40 by 60, giving us 0.666. 360 divided by 0.666 gives us 540. So in our range mapper here, we'll place 540, which of course is half of 1080, at the output upper, and then we can sort out our planet cogs. On this occasion, we can divide 1440 by 2, giving us 720, and we don't need a minus sign. So we should, all things being fair, and we just need to reset things to 0, but all things being fair, this should actually work. I'm going to just zero everything out, so we'll zero out the carrier, and there we are. Now let's try this and see if it actually works. At the moment it is not, and the reason for that of course is because we need to be driving the ring. So let's just bring that into there and try again, and now we've got it working. Fantastic. So that's our 6th and final scenario complete. To finish things off, we'll add another tag to our Expresso null, another programming tag, Expresso, and we'll create a reset. Now with our Expresso selected, we need to add some user data, so we will do that. We'll add a group and call this initialize. Don't want too many eyes in it, so we've got initialize there. And our data we can drop in, and we'll just call this reset. It needs to be a Boolean, and that's what it needs to be, a checkbox, so that's fine. We'll just click OK. So we've got that set up for us. The next thing to do is drag in the Expresso null and select reset from the initialize menu. We can then bring in an iteration. We'll need one of those, and it will need an on port added to it, and we'll use the reset to control this. Our iteration start will be 0, our end will be 8, because we want to sequence through 9 objects, and to do that we need a linked list. So we'll bring one of those in and connect the iteration output port to the index port, and then we can think about populating our linked list. For a start, we need the carrier assembly. We also need the sun and ring, and then all of the planets, giving us 9 elements. So we've got that sorted out. The next thing we'll bring in is a constant node. So new node, Expresso general, and we'll select our constant node. And we need to leave its value at 0. And then all we need to do is bring in, just say P1, that'll be fine as a placeholder. Give it an object port, give it a rotation B port. And then all we need to do is connect our link list to the object port and our constant to the rotation B port. And that will enable us to zero everything out when we work with our reset user data. So let's just give this a test and see if it actually works. We might as well use that one actually. We'll use the carrier assembly. So let's just rotate this. And then with our Expresso, we can just check the box and we can see that it does reset things. And this will work with all of the scenarios, so you can test those out for yourself. But that essentially is how you go about creating Planetary Gears. And you've got all the 6 scenarios all set up and ready to go, and all you need to do is just choose between them. So switch this one off, select the first one, enable that one, select the sun, and it will work, provided at the moment it won't do anything. So you've got to make sure that this isn't checked, and then you can move it and it will work. Okay, so that's how you go about doing it. And that just about brings us to the end of this tutorial, the last one of 2023. So as always, I really hope you've enjoyed doing this one and that it's given you some ideas for things that you may be able to incorporate in your own projects. And if you have enjoyed the video, please give it a like. And if you haven't already, please subscribe to the channel, leave a comment, and of course, ring the bell. And wherever you happen to be on social media, please do share this video, because all this good stuff really does help keep the channel moving in the right direction. But anyway, that just about brings the curtain down on this one and of course on 2023. So I'll see you very soon in 2024 on the next tutorial.